Hi everyone, my name is Daniel. I'm the lead maintainer of Inspect WandB, which is an open source integration between Inspect, the safety focused LLM evaluations framework, and Weights and Biases, the popular machine learning experiment tracking platform. And today I'm going to be walking through a tutorial of how you can use Inspect WandB to augment your existing Inspect workflows. So to start off, I've brought up our documentation page. This is probably your first port of call if you're using the extension and having questions or any difficulties. But before we dive into some examples, I wanted to just talk a little bit about the use cases that we had in mind that motivated building Inspect WandB. So when you use Inspect, the results of your evaluation will be logged to this .eval file, but by default, they're not going to be logged to a sort of shared cloud-hosted system that makes it easy to do some analysis of those results. And that's the problem we were trying to solve with Inspect WandB. So we think it's really useful to automatically be able to share data about your Inspect runs and be able to do some sort of light analysis of your results in the cloud. And Weights and Biases gives you a lot of that stuff for free. So basically allows you to do some filtering and sorting, comparison across different runs. You can analyze transcripts and different sort of scores or performance metrics like tokens used or cost, and also makes these experiments a bit more repeatable because you're logging the exact configuration that you use to do a given run. And before we dive into the code, I just also wanted to briefly explain the difference between Weights and Biases models and Weights and Biases Weave. These are two different APIs that are exposed by Weights and Biases. The first one, models, is the kind of traditional experiment tracking for training runs, but we've commandeered it here to log the exact configuration that was used for your Inspect run. Whereas Weave is more purpose-built for LLM evaluations, and so you get some nice kind of results analysis or like transcript analysis tooling through that. So diving into a couple of examples. So I've got this example Inspect evaluation from Inspect docs, and basically the first thing we should do is install the extension. So the extension by default is only going to integrate with the models API, but you can add this Weave extra when you're installing it from pip, and that'll give you the Weave features. And then in order to get set up, you need to log into Weights Biases, which I've already done. And then you also need to initialize the project and entity that you're going to log results to. And if you don't have interactive terminal access, there are a couple of other ways that you can move through this flow, but we think this is the easiest one. So it's probably a good place to start. So once you've installed the integration, the next step is just to run Inspect. And here we're going to run this evaluation for 10 samples and GPT 4.1 Nano and Claude Haiku. Because it's a relatively easy evaluation, I've chosen two models that are sort of maybe not going to just get 100% on it, because that might make it a little bit more interesting when we do dive into the results. So while that runs, let me just move back to the documentation and talk a little bit more about the installation and setup. So when you install the integration from pip, as I mentioned, you can add this Weave extra to get those additional Weave features that we'll see in a minute. And then when it comes to setting up Weights and Biases, you have a couple of different options. So if you have interactive terminal access, you can use WandB login as I did. But if not, you can just set the WandB API key environment variable using an API key from Weights and Biases. So that would be useful in a sort of deployed or like automated batch pipeline setting or something like that. In project and entity, you have a few different options. So there's the option that I chose, which is running WandB init in your terminal and following the instructions. This is quite useful if you want to set the project and entity for the current working directory only. So if you run WandB init, that will set the project and entity for only the directory you're currently in. But if you wanted to set it at the project level, then you can add this tool block to the pyproject.toml. You can also set environment variables for setting the project and entity, which is, again, useful in this automated case. And then the most granular option you have is to set the project and entity at the level of a single inspect run, which you can do by passing this metadata argument to inspect eval or inspect eval set. And I'll go into that a little bit more in a minute. So if we go back to cursor, we'll see that the evaluation has run, and in the inspect output, we get these URLs which link to weave and weights and biases respectively. So let's follow one of those. So this is the weights and biases run for the inspect eval that we just ran. You can see these charts which track the samples and accuracy over the course of the run. These charts at the moment are not terribly useful. This is something that we're planning to improve in the future and give you a little bit more flexibility over, but for now it's just going to log number of samples and accuracy if that's appropriate for the given evaluation that you ran. But perhaps more interesting is the overview of the run, which will tell you exactly the configuration that was used to run this evaluation. So you can see all my sort of system information and also a link to the Weave dashboard for this run, and also a link to the inspect logs which correspond to this run. So this can be quite useful for flipping back and forth between weights and biases and inspect. Another thing you can do is log files. So by default, some of these files from your system will be logged alongside the run, but you can also configure this in the Inspect WandB settings, and I'll get into that in a minute. And then if we look at the Weave dashboard, which is this evals tab, we can actually do a little bit more analysis of how the models performed overall. So we can see here for our run on Hellaswag, there was two different models, GPT and Claude. They both achieved the same score on the evaluation, and there were 10 samples. And we can also see some other metadata about the run, like the inspect eval ID and the run ID. And also it's going to track the number of tokens that were processed and also the cost and latency of the evaluation. So then that's the highest level you can look at these evaluations, but you can also step in a bit more detail. And one interesting way to do that is to go to the child calls of the evaluation, because each child call of the evaluation corresponds to one inspect sample in a given epoch. So then this allows you to find the examples where the model failed or where it succeeded, depending on what's more interesting for your evaluation, and then dig in a little bit further. So yeah, you get presented with this trace view, which basically shows exactly what happens during the processing of one inspect sample. So you can see here that there's the system message and the solver, which was a multiple choice solver. The scorer was the choice scorer, and then these weave traces which track the total time and tokens. And one interesting thing you can do here is look at the traces corresponding to the model calls, because this gives you this chat interface that you can use to sort of dig into interesting transcripts a bit more. In this case, it's a multiple choice benchmark, so maybe that's not so interesting, but we'll look at another more interesting example in a minute. Yeah, this trace view can be quite nice for navigating through and finding some examples where the transcripts were a bit more interesting, one possible use case. You also have some other data in this table relating to the time for processing each sample and the number of tokens used, and some metadata such as sample IDs that can help you sort of track across different views. So going back to the evaluations table, another interesting thing that you can do with Weave is compare the results of an evaluation on two different models. So here we can see that the models had the same performance. So, you know, there's not much difference between any of these charts, but what we might be interested in is looking at specifically where did the models differ. So actually we can see that although the models got the same performance, there were a couple of examples where one model was correct and the other model was not correct. So for example, here we can zoom in on this case where the Claude model was correct and GPT was wrong. And then we can step in and see what was the sample. That might be an interesting way to find these kind of samples where there were sort of anomalous results. And then finally, I also ran a sort of more agentic evaluation earlier. So that's this agent harm evaluation with Claude 4 Opus. And we can check out the trace tree for this one and see that it's a little bit more involved. So yeah, we have a more complex trace tree that tracks all the different parts of the solver, like the setting up tools and injecting the system prompt. And we also can see that in some cases there's multiple API calls within a given generation. And this can be an interesting case because this usually means that there are tool calls, and the transcript view allows you to see exactly what tools were called and what their outputs were. And this can be quite a nice way of finding different anomalies in the tool calls. Possibly there can be errors, but also just like unintuitive usages of the tools. And yeah. So yeah, that's the dashboard. Back to the docs. So the last thing to talk about really is configuration. There are a few different settings that you can use to configure the integration for different purposes. These are fairly basic at the moment, but especially for weights and biases models, you can configure these following settings. So you can turn the integration on or off using this enable setting. You can configure the project and entity as we discussed before. You can add config. So this will be passed to the wandb.config function. This is primarily useful for training runs, but it's possible there are some things which are useful for LLM evaluations, and you can see more details on weights and biases docs. As I mentioned, you can decide which files you'd like to log alongside your run from your machine. You can also add tags. So if we go back to the run, and you have this like runs table, which shows you all of your different runs. And here by default, we're going to add a couple of tags that tell you what the data set was and what models were used. But you can also add custom tags to help filter and sort your models if that's useful. And then there's also a setting for adding metadata to the config. So by default, this is true. We're going to just write the entire inspect metadata to the weights and biases run, which can be useful for tracking purposes, but for whatever reason you didn't want to do that, you can turn it off. And then the last setting is this environment validation setting. So there are a couple of different environment variables that our integration doesn't actually interact with, but will affect where the results get logged. So the WandB base URL and the WandB API key. And given that some safety evaluations contain sensitive data, you might want a little more peace of mind that you're only logging results to your project and nowhere else. And the environment validations allows you to use the extension to perform some validations before logging any data. For Weave, you have the same enabled project entity settings, and then also this sample name template. So if we go back to one of the trace trees, we can see some of the traces have this name which identifies the task and the sample and the epoch, and you can actually configure what you want those traces to be called. If you felt that there was something more informative, you could configure that using this setting. As we already discussed, there are a couple of different ways to configure the settings. So the highest priority way is by adding these metadata flags to the eval or eval set command. The next highest priority is setting environment variables, which is useful for the sort of automated environments. Third priority is this WandB settings file. Now, this only works for the WandB project or the WandB entity. You can't actually set any of the other settings using this. Then lastly is the project level pyproject.toml settings, which, yeah, you can use these blocks. So it's worth reading through this if you think you might want to configure some of these settings. There's a big table at the bottom that shows you all the different ways that you can configure any of the sort of given settings. So yeah. And yeah, we have frequently asked questions. There aren't that many questions that have been asked more than once, but if you have some questions, they might be answered here. And if not, you can tell us on Slack and we'll add them to this page. And then lastly, I'll just talk about contributions. So it's an open source project and we would love contributions. We have some issues on the GitHub. So if you're looking for something to do, then you can have a look through there or chat to me on this Inspect WandB Slack channel and the Inspect community Slack. But as well as actually writing code, it would be really useful for us if you have any feedback at all about using this tool. We would love to iterate based on user feedback. So please do get in touch if you've been using this and enjoying it or finding it completely useless. Either way, you probably have some good feedback for us. And then if you want to dive into the code, I'll also put the link to the GitHub in the in the description. So you can check that out as well. Give us a star if you're feeling generous. And yeah, I think that's it. Thanks for watching this tutorial. I hope you have a good experience using Inspect WandB. And yeah, please get in touch if you have any further questions.